Hi everyone, welcome to BYJU'S Exam Prep, India's most comprehensive preparation platform, and it's a one-stop destination for all your preparation needs. Any exam, BYJU'S is one-stop destination. So this session is on BARC and HAL series. So I'm gonna revise. I'm gonna cover few models of questions on signals and systems, so that it will be like a refreshing session on signals course, right? So let me start with the session. So I have 10 plus years of experience and I've done my masters from IIT Madras. So I worked for a lot of coaching institutions earlier. So I worked for Medici, I worked for an academy, I worked for Engineers Circle, and I've been working for a lot of other institutions as well for the last 10 years. And my area of expertise is communications and signals and systems. So my same master's expertise is what I'm teaching right now. And so for any doubts on signals and communications, you can contact me on this Telegram group. Right, so there is one interesting session that is happening in tomorrow's class, tomorrow at 6 o'clock. At 6 o'clock, I'm taking BARC session only. The second part of this signals session will be there at 6 p.m. And there is one more interesting session that is happening tomorrow at 9:30 p.m. And that is a session on how is life at IIT Madras. So I'm going to share some interesting stories about what happened with us in IIT and what we learned and what are the opportunities that we might have missed and what are the most exciting things that we have done and what I could have done better. Okay, what are my mistakes, what I could have done better, and what are the lot of learnings, whatever learnings that IIT has given me. So all those things I'll be sharing with you guys. So don't miss the session. And you can ask me any questions regarding IIT Madras or any other IITs, because most of the IITs will have similar facilities and similar stuff. But tomorrow it is more of my journey at IIT Madras and my learnings and other things. Okay. So good evening Jansi and good evening RR. It should be one more R means it would have been good. It would have become triple R, which is very popular right now. Fine. So shall we start with the session then? So one session is happening on 13th March, Strategy to Conquer. So if you're interested, you can attend that session. Right. So let us start with the first question. So you can try and answer this question. So I'm talking about, I've given you a signal, exponential signals, and the options given are, is it an energy signal or a power signal? And I'm giving you other options also based on energy and power. Can anyone comment about this? Hi, Aman Gaur. Shankar Shan, my place is Tirupati. I'm from Andhra Pradesh. Anyone can answer this? Energy signal. Sure? Surajit? Hi Surajit. Any other answer, or are you sure that it is an energy signal? Others also can answer. It is option A, Shankar. You're saying it's A? Okay. Let me wait for 30 more seconds. And before locking in the answer, you have 30 more seconds to think again. Okay, once you do some question in the exam, once you look at an option, you fix on that option without cross-checking twice, even though you have a chance. So that mistake we all do in the exams, right? So don't do that mistake. We might have done a lot of silly mistakes like that. You know the answer, but somehow you missed it in the exam, right? It's a power signal. Shivajit is saying power signal. Anyone else? Any other answers? Sir, only 4 options are there. Already 2 options are picked. What else can be the answer? You tell me. You have to think carefully. I have put small twists in every question. You have to think carefully. Okay, fine. So let me get to the answer, okay? Can anyone draw this signal? Draw this signal and this signal? Just draw it in your mind. As I told you, I've put a small trick here. I don't know if you have picked up that trick or not. Right. I have not given e power minus 3t into u of t. You have to mind this. This is not what I have given. Okay. I have given you e power minus 3t, just e power minus 3t. E power minus 3t into u of t, that looks like this one. Exponentially decreasing signal which exists only for positive time. Whereas this is a different signal. This is a different signal. So let me plot it. So it looks like this. This is how it looks like. This is how e power minus 3t looks like. E power minus 4t also looks similar. Looks similar, definitely. Maybe the rate at which it decreases changes, but similar shape will be there. Okay, you might, all of you have thought that there is u of t. You missed that u of t part. That's why you have answered it as energy signal. Right? Now can anyone answer it? Now what is it? Is it energy signal? Is this an energy signal? If you observe, this signal has infinite amplitude. At minus infinity, it has infinite amplitude, which means energy also will be infinite. Any signal which has infinite amplitude will have infinite energy also. So this has energy as infinity. Whereas this one, you thought this is the signal that I have given. For this one, energy is finite. So this signal has infinite energy. This also has infinite energy. Two infinite energy signals, correct? So the energy is finite means then only we can call it as energy signal. If power is finite, then only we can call it as power signal. Okay, right? Energy of the signal is infinity. Option C matches with our analysis. But it is not energy signal because energy is not finite. It is also not power signal because power is also not finite. Any signal which has infinite amplitude, has energy and power both as infinity. Okay, any signal, if you take impulse or any signal which takes infinite amplitude at any single point of time, it will have energy and power both of them as infinity. So those signals will be like neither energy nor power signals. Okay, next time no mistakes like this. Okay, unstable and a periodic signal. Relax. Unstable. Can you call a signal as unstable signal? Can others answer me? Our friend Relax today is saying that it is an unstable signal. Can you say a signal is unstable? We can never talk about stability for a signal, right? Okay, I understand your meaning. Okay, the signal is not absolutely integrable. That statement is perfect. Okay. Yes, a signal is actually MSQ. My intention is to give an MSQ only. So power of the signal is also infinity. Yes. Power of the signal is also infinity. It was an MSQ question and fourth option is also correct. Okay. Surajit, system, yes, system, if I have given you, instead of a signal, if I have told you that this is the impulse response of a system, if I am talking about impulse response of a system, which also looks like a signal, okay, then only you can talk about stability. Signal stability does not make any sense, right? Okay, sometimes some teachers mention the word stability just to say that, just to talk about the thing called absolute integrability. If the signal is absolutely integrable, okay, sometimes some teachers might have called it as stable signal or something like that, but that's not a perfect wording. Okay, never call signals as stable or unstable. They are absolutely integrable or not absolutely integrable. That is more sensible words to use. Okay, fine. I hope that is clear. Okay, shall we go to the next question? Okay, next question. I've put small twist here also. Just observe carefully. Observe carefully, don't make any mistakes. No silly mistakes here. At least in this question, no silly mistakes. U of t is given, but some other trick I have put. Observe carefully and answer. Come on. Who will answer me the fastest? It's option E. Think carefully. Think carefully. When you get an answer, is there any chance that that may not be correct? Just think of the other way also. C and D. Okay, Shankar. C and D. Okay, think again. Think again. You might be right or you might be wrong. I'm not sure. I'll tell you after some time. Here both are constant signals. Are you sure? Their amplitude is constant. That's a good observation. They are not constant signals. Their magnitude is constant. Anthony, Ronald, it is B. Okay. If power is finite, we call it as power signal. Or signals which are infinite in amplitude, infinite in time, and finite in amplitude, those kind of signals, we call them as power signals. Finite in amplitude, infinite in time. Those signals we call as power signals. Okay, let me get to the answer. Say this one. There is J factor here. When there is J factor, its magnitude never takes infinite value. Its magnitude always takes one value. Magnitude of e power j term, e power j theta, e power j theta is having, e power j theta is nothing but cos theta plus j sin theta, right? What is the magnitude of this? Magnitude of this is always 1. Anything is beside j, anything, any complicated term beside j, that's fine. If it is in the power, if there is a j term, its magnitude is 1. I'm not saying everything is 1, its magnitude is 1, its phase can be something. Okay, since magnitude is 1, magnitude is never becoming infinity, magnitude is finite, but since u of t is there, that signal exists for infinite duration of time and its magnitude is finite. So finite amplitude, infinite duration signal, this is the power signal. Because, or else look at this way, cos and sine terms are involved in this, cos and sine term signals are power signals. So since cos and sine signals are involved, this signal is also a power signal. Similar signal only, whether there is minus term or not, when there is j in the power, no amplitude will not matter. What is the function in the power? That does not matter. If there is j term, its magnitude is 1. Sine and everything else is immaterial for us. So amplitude of this signal is also, magnitude of this signal is also 1 at every point of time. It is never taking infinite amplitude. So which means it is not a neither energy nor power signal. And if you observe, it's a constant signal with infinite duration of time, so its energy is infinity. Its energy is infinity, but its amplitude is never infinite, which means it's neither energy nor power. It's not neither energy nor power signal. So it's not energy. It's not neither energy nor power signal. The only option is it's a power signal. Okay. So both of them has infinite energy because they are infinite duration signals. And since they are having finite amplitude, their power is finite. Okay. So it's a power signal. Energy of the signal is infinity. Yes, that is also correct. Is the power of the signal infinity? No, right? Because e power j term means it's like cos and sine terms are involved. Cos and sine terms, their power is finite, right? A cos omega naught t. What is the power? A square by 2. Power is finite, right? So we know that whenever e power j terms are involved or cos and sine terms are involved, their power is finite. When power is finite, they are power signals. So energy of the signal is infinity, correct? Power of the signal is infinity? No, it's not true, because these terms have finite power. They have infinite energy, but they have finite power. Fine. So it is also an MSQ question. Right? Shall we move on to the next question? If you are having any, Anthony, you are correct, but I think third option also you should. If you have it picked, I would have been more happy. Okay. Right. Let's move ahead. Come on, it's a simple question. Let's see who will answer first. I've given you a signal and its power. I did not give you the details of the signal. I have only given you the power of the signal. Oh, okay, 1 second. There's a small mistake here, typing mistake. I'm not giving you power here. I'm giving you energy. Both terms should be energy or both terms should be power. If power is given, I can find the power of some modified signal. If energy is given, I can find the energy of the modified signal. So I assume that energy is given as 20 units. What is the energy of the signal? X of t by 4. Anyone can answer this? Anyone? 80, yeah? Okay. Wonderful. That's a very good, very quick answer. I appreciate it. Very nice. Since people have answered already, let me do it. X of t has an energy of 20 units. I'm asking you what is the energy of X of t by 4. Try to understand. You don't need to by heart anything. X of t by 4 means it's like expansion. For example, just take some example for X of t, some signal like this. Let's say 0 to 2. Now X of t by 4 means it is expansion by 4 times. If it is from 0 to 2 earlier, if you do X of t by 4, it will be from 0 to 8. You have expanded in time by 4 times. The amplitude remains same. If it is a earlier, now also it will be a. Earlier the energy is a square into 2 is the energy. Now it becomes a square into 8. Since the in time axis it has increased by 4 times, energy also increases by 4 times. Or else, in this example, let us calculate. Energy is square the signal and find the area. A square into 2. In this case, energy is same a square. Since time axis it has expanded by 4 times, the constant that we are multiplying here 2, now it is becoming 8 because we are expanding in time by 4 times. Just imagine what is happening to the signal in time domain. Since in time domain it is expanding by 4 times, its energy calculate. Energy is nothing but area of squared signal. Area of squared signal. That also increases by 4 times. So it will become 20 into 4. Okay. Shall we move on to the next one? Let's move on. Find the energy of the signal. I've given you some signal. Try to do it. What you should do is directly you will not be able to find it. Mathematically it's difficult to find the energy just by looking at it. R of t energy, R of t minus 4 energy, that way you can't find it. The only way to find it is you have to plot it. If you can plot it quickly, then only you can find the energy. Is there anyone who can tell me the energy quickly? Is there anyone who have figured out the energy? If you have figured out the plot of it, if you have imagined the plot of it, then it's easy to figure out the energy. Is there anyone who have done that? T by 3. Sarajit. Okay. Kindly check your plot. Whatever is you have plotted, the graph of y of t, make sure that it is correctly plotted. If it is correctly plotted, then only you will get the answer correctly. First, be careful about your plot. It is an easy signal to plot. First plot R of t minus 4, and then subtract it, you will get some signal, and then subtract u of t minus 4 from it. Anyone? Come on, what happened? Anthony, relax today. Shivajit. Shankar also same answer, 64 by 3. Cross check your answer. 3 people have answered the same thing. 32. I'm yet to get a person who will give me the right answer. Which means I'm already telling you that your answer is wrong. Anyone else? Come on, I'm already telling you that it's a mistake. So rectify your mistake. Hi Rakesh, hello. Come on, guys. No mistakes. Shojit, come on, man. You have given me 9/2. Then you are saying it is 4.5. That's wrong. Come on, come on, come on, come on. Anyone? Any one person? I want right answer. It's not a question which you can make a mistake. Okay. Last 10 seconds I'm gonna wait. And then I'm feeling itchy to solve it. Come on, come on, come on, come on, come on. I'm done. My patience is done. I'm gonna do it. Okay, fine. So if you are not comfortable with plotting, let me plot it individually. So this is how R of t looks like. And R of t minus 4 looks like this, which starts from 4. This is how R of t minus 4 looks like. Okay. And let me first find the resultant of these two, okay, so that it will be easy. For people who know how to plot it, then for them you can directly plot all three together. If you subtract these two, R of t, what is the value of it at 4 units? At 4 units, R of t will have a value of 4, because R of t equation is t into u of t. At t equal to 4, it will become 4. Right. So at 4 units, from 0 to 4, this graph minus 0, anything minus 0 is same thing. So same graph I am replotting here. And the height is, what is the height at 4? It is 4 units. Okay. And after that, it is also increasing at the rate of 1 unit increase for every 1 unit on a time axis. This is also increasing at the same rate. If you subtract, it is increasing by 1 unit, this is also increasing by 1 unit. If you subtract both of them, the slope of this is 1, slope of this is 1. If you subtract two signals with same slope, what happens? It remains a constant signal. So if you subtract these two, it will remain a constant signal. From 4 onwards, it remains a constant signal. What is the height of it? 4 units. So what should you subtract from this so that it will become a simple triangle signal? You should subtract with 4 into u of t minus 4, not just u of t minus 4. Okay. So let me plot it. After subtracting with this, this one, from this one, I'm going to subtract u of t minus 4. I think you can imagine how u of t minus 4 looks like, right? A constant signal which starts from 4. A constant signal which starts from 4 with a height of 1 unit. The height of this is 1 unit, whereas we are having a height of 4 units. 4 minus 1 will become 3 units. So the resultant signal is going to look like this. The height is 4 here, and after that, it becomes 3. So this height is 3. Now tell me what is the energy. Can anyone tell me what is the energy? It's an infinite duration signal, na? It's an infinite duration signal. Energy is what? Square the signal and find the area. If you square it, it's finite amplitude, agreed. If you square it also, it will be finite. So finite amplitude, but width is infinite, no? So if you find the area, width into height, it's something like that, no? When the width is infinity, infinity multiplied with amplitude is finite. Finite into infinity is infinity. Looks easy after I do it. You're making small mistakes, you have to rectify them. Otherwise, we can't crack competitive exams. You might be knowing the subject very well, but if you miss more simple things, then we can't crack the exam. You have to correct these things. Nobody gets immediately after the preparation. Nobody will get to a stage where no mistakes will be happening. For everyone, mistakes will happen. For me also, a lot of times I have made a lot of mistakes. But we have to correct ourselves. Okay. Next time onwards, keep this in mind. Okay. We have to rectify. We have to improve ourselves. It's not like we can't go to a stage immediately just like that. That will not happen. We have to improve by writing multiple exams, correcting ourselves, correcting writing. On the part after subtracting u of t minus 4. Okay, one second. Some people are asking some questions. Shojit, you are answering me the power part. You're saying power is 4.5, huh? I don't think power will be 4.5 because maximum amplitude itself is 4. No? How can I don't think power will be 4.5? It will be less than that. Power is finite, that much I'm fine, that much I'm sure. But here I'm asked you energy of the signal. No? If you have answered me power, let's assume you have answered power correctly. If you are answering power, how can I say that it is correct answer? Okay, so fine. But power definitely it is not. I think it's not 4.5. You can calculate it again and let me know. It will be much less than 4.5. Okay. Next, Venu, this will have power. Yes, this definitely Venu, this will have definitely power because this is a power signal. Its power will be finite only. Its power will be finite only. And anything else? Rakesh, you're asking something? Anything else you want me to answer from this? Any confusions you have, you can ask me quickly so that no mistakes will be made next time. If you have any question, if you get the question later also, that's fine. You can ask me later also, not a problem. Okay, don't mind asking questions. More questions you are getting means you're figuring out things. You're not getting doubts means you're not improving. Okay, you're not getting new. You're not learning new things. On the part after subtracting u of t minus 4 graph. You're asking me about that graph. Okay, fine. So this graph is there, right? So this is subtraction of these two, and then we are having see this one. This is u of t minus 4. Subtract this from this. Okay, how do you subtract? 0 to 4, this is having some graph, this is not having any graph. Something minus 0 will be the same thing, right? So same graph I have copied here, as it is, whatever is here I have copied here. Next, after 4, both are having signal. After 4, this is having a height of 1 unit. After 4, this is having a height of 4 units. 4, constant signal 4, and here it is constant signal 1. Constant signals, it's the easiest subtraction that we can do. 4 minus 1 will be 3 units. So after 4, it will be 3 units graph. Okay, but there is a discontinuity. Maybe there might be a confusion for you about discontinuity. Whenever there is a discontinuity, you have to do the subtraction or addition before the discontinuity and after the discontinuity. So before the discontinuity, just before 4, what is the height of it? 4. Just before 4, what is the height of it? 0. Just before 0, just before 4, take the height of both of them and then subtract. It is 4 units here and it is 0 units here. 4 minus 0 is 4. That's why I've drawn it as 4. Okay, whenever there is a discontinuity, don't try to do the subtraction or addition at the discontinuity. Because this is a discontinuity, no? There is a discontinuity at 4. So don't try to do the calculation at 4, because at 4, the amplitude is not 1. The amplitude is undeterministic. We don't know the amplitude at 4. Amplitude will be anywhere between 0 to 1, but we don't know the exact amplitude at 4. At 4, there is an undeterministic amplitude here. At 4, it is having an amplitude of 4. 4 plus undeterministic is undeterministic. We can't determine because it is a discontinuity. There is a discontinuity at 4 here also. I hope you are following. Shankar, you want me to calculate the power? Okay, let's do it. Wonderful. Okay, since the signal is plotted here, let me calculate the power here. If you want to calculate the power, how do we do it? Square the signal and find the area, or else let me write the formula for power, right? Power is energy you can calculate and divide with total time. That also we can do. Energy is square the signal area. Power is find the energy and then divide with total time. That is also fine. Power of x of t is equal to limit t tends to infinity integration of mod x of t whole square dt, limits from minus infinity to plus infinity, This part is the energy part. And when you're doing 1 by t, you're finding the power. Because t is the total time. Because the total time is infinity, we can't substitute 1 by infinity. That does not make sense. So that's why we're finally effectively substituting infinity in place of t. Fine, last at the end. So, and we are integrating it from basically from minus infinity to plus infinity. But once you substitute infinity and minus infinity, it will become undefined. So that's why what we do is we go from minus t to plus t, and then you'll get a function of t, and then you divide with t, and then you're going to substitute t in place of t infinity. So this is how we calculate the power. Effectively what we are doing is we are finding the energy and we are dividing with total time. We are doing not doing anything more than that. Power is nothing but rate of energy or energy spent for 1 second of time. For every second, how much energy you are spending, that is power. Okay, let's do it. If you square this one, let me square it. So 4 square is 16, the height will be here 16, and this is mod y of t square. Okay, so what is the area till 4? Till 4, whenever there is a parabolic signal like this, or else when you square a linear signal, when this kind of signal is squared, it becomes parabolic, and the area is 1 by 3 into base into height. What is the base here? 4 units, height is 16 units. For triangle, you do half into base into height, right? So when you are having a parabolic signal, it's like instead of 1 half into base into height, it's like 1 by 3 into base into height. That will give you the area. So which is equal to 16 4 is 64, which is 64 by 3 is the energy of this part. And how about the energy of this part? It is 4 to infinity. It is 4 to infinity, but instead of infinity, since the upper limit is t, let us integrate it till t. T is infinite time only, but let us integrate till t. T minus 4 into 16. The area of this part is t minus 4 into 16. So we got the total area, add these two, we got the total energy, which is limit t tends to infinity, 1 by t into, what did we get? 64 by 3 plus t minus 4 into 16. Okay, now let us substitute t equal to infinity. So when you substitute t equal to infinity, 64 by 3 by t, if you substitute t equal to infinity, this first part in the denominator t is there, so it will become 0. In the second part, t by t becomes 1 minus 4 by t. That part, if you substitute t equal to infinity, second part becomes 0. So t by t, the first part will become, t and t gets cancelled. There is no substitution in this place. So it will become, this part becomes 1 into 16 is 16. What is the answer? 16, yeah. Yeah. So I told you that it will be less than 4.5. My mistake, it's not less than 4.5. It is more than 4.5 because I did not square it actually. I thought it will be less than 4 because I forgot to square it. When you square it, it is 16. The height is, maximum height is 4, right? So maximum squared value is 16. Is it correct? Have I done any mistake here? T minus 4 into 16. That's perfect only. Yeah, one small mistake I've done. And what is that? Anybody can identify my mistake? Yes, you told me. I did not see your chat. It is 1 by 2t, correct? It is 1 by 2t. Because total limits is minus t to plus t, which is 2t, right? So because of 2t, what is happening here? Because of 2t, I hope you have understood this part. I have explained it orally. If there is any confusion, I will explain it once again. So first part becomes 0. Second part is t divided by 2t is 1 by 2. And outside it is 16 minus, it is 16 into 4 is 64 divided by 2t. If you substitute with t equal to infinity, it becomes 0. So 16 by 2 is 8. Final answer is 8. Yeah, calculating power, it is taking some time. But whenever you get questions like this, means I've asked you some question, but some of you have thought of how to calculate the power. That's a good thing to do. Whenever you face some question, you try to answer other questions that can be asked from the same question. So that's a good way of solving the questions. If you solve it that way, it's solving one question is equivalent to solving 5 different questions. Okay, fine then. Suffocating. Let me switch on my AC. Okay, shall we move on? Very good. Shivajit, you have been telling me, but I did not see the chat. I was busy with solving. I'm moving on to the next question. Similar type of question. I think you should be able to answer this question. Okay, let me go to the previous question once. Let me ask you now, if I want this signal to have a finite energy, then what should be the change? If I want the signal to have finite energy means it should be an energy signal. It should not be existing for infinite duration of time. If that should be the case, then what should have been the amplitude of u of t minus 4? Anyone? What should have been the amplitude of u of t minus 4? You are subtracting this and this one. This one you are subtracting from this. This is having a height of only 1, whereas this is having a height of 4. If this was also having a height of 4, then 4 minus 4 would have become 0. Only this triangle part would have been there, and its energy would have become finite. Okay, so it should have, if there was a 4 here, then it would have become an energy signal, and the energy that you find will be finite. But finally, I forgot to write the answer here. And what is the energy here? Infinity. I've asked only energy. Definitely that is infinity. We have also calculated the power as per your request. The power is 8 units. Okay. Now similar question I'm asking you. Anyone can answer this? Is there anyone who can answer this? Come on, you have to visualize. Activate your visualization. The more you use your visualization skills, the faster you can answer things. Come on, you should be able to plot the graph of this in the mind itself. R of t minus 15. First plot these two. R of t minus t plus 5 minus R of t minus 15. R of t plus 5 means it starts from here. Minus 5. R of t plus 5 starts from minus 5. So it's a ramp signal which goes on increasing. It goes on increasing if that is the only signal that is there. But R of t minus 15 is there. It is also another ramp signal which starts at 15. I want to plot the combination of these two. Okay. So R of t minus 15, it starts from 15. Since both have same slope, 1 unit, since you subtract two signals with same slope, you'll get a constant signal. The result will be a constant signal. I'm plotting only these two. These two signals I've plotted. And what is the height here? Anyone can tell me what is the height here? If you are able to figure out the height here, the problem is done. What is the height there? Ramp signal. So from minus 5 to 15, there is only one ramp signal that is existing. Only this ramp signal. This ramp signal is starting from 15. Till 15, only one ramp signal. And what is the slope of this? 1 unit. The slope of it is 1 unit. What is the meaning of slope? For every 1 unit, when you travel 1 unit in time axis, if the slope is 1, the height also increases by 1 unit. So, since we know the slope is 1 unit, minus 5 to plus 15, distance is 20. You can imagine a right angle triangle there. Since we know the slope is 1 unit, 20 units is the width. Since the slope is 1 unit, angle should be 45 degrees. Or in 20 units time duration, the height also will increase by 20 units. That way you can figure out the height easily. Okay. Or else if you want R of t plus 5 equation, you can write and you can substitute the time 15 and then also you can figure out. R of t plus 5 equation is t plus 5 into u of t plus 5. T plus 5, what is the value of t plus 5 at 15? T plus 5 substitute with 15, it will become 20. That way also you can figure out. You can figure out in multiple ways. Right. I've plotted only these two. Now, the third one, u of t minus 100. U of t minus 100, how does it look like? Let us plot it. I did not write u of t minus 15. That is the trick I'm playing here. I did not write t minus 15 just to confuse you. You should not get confused. Okay. So t minus 100 means it starts from 100. Now I'm subtracting these two. What should be the height of this? What should be the height of this so that this becomes an energy signal? Energy signal means what? Width should be finite. Height should be finite. Width also should be finite. Then we can call it as energy signal. So if you subtract these two, is there a chance of the resultant signal, the subtraction of these two signals becoming a finite duration signal, finite duration in time signal? It is possible, no? This is u of t minus 100. If the height of this, the height here is 20 units. If the height of this is also 20 units, then the resultant signal will stop at 100. If the height of this is anything other than 20, then the signal will not stop. The resultant signal will be existing till infinite duration of time. If the duration of time in which the signal exists is finite, definitely it will become an energy signal. What did they say in the question? Find the value of A so that y of t is an energy signal. Energy signal, if you want it to be an energy signal, width of the signal or time duration in which it exists should be finite. Finite means anything countable, we can call it as finite. Anything other than infinity, we can call it as finite. Right? So if you subtract these two, the height of this is given as A. Okay? Okay, let us do it in a very basic way, okay? This is 15, this is minus 5, and then till 100, the height is 20. Same thing I'm copying here, nothing more, nothing less. Till 100 I've copied. After 100 what is happening? This signal is also starting. So what I want is, I want to plot y of t. I want to plot y of t, which is subtraction of these two. Subtraction, first two signals we have plotted in this graph. Third signal we have plotted here. The height is A. Now if you subtract these two, the height here is 20 and the height here is A units. The subtraction is 20 minus A. The subtraction is 20 minus A. This is how it looks like. This is 20 minus A. If the signal is like this, will it be an energy signal? If 20 minus A is not 0, then it will be an infinite duration signal. It will not be an energy signal. But what do we want? We want an energy signal. If we want an energy signal, we want a finite duration time signal. If you want it to be a finite duration time signal, it should stop at some place. What is the possible stopping point? At 100 it can stop, provided 20 minus A is 0. If 20 minus A is 0, there is a possibility that it can stop at 100. Width is finite, it becomes an energy signal. So if you want 20 minus A to become 0, A should become 20. Right? So the answer is, if A becomes 20, then definitely it will stop at 100. The width of the signal becomes 100 units. Finite width, finite height, it becomes an energy signal. Okay? Is that clear? Any doubts? Anyone? Anything you want me to explain once again? Anything you want me to explain once again? You can ask me quickly. Can I assume that you've understood? If there is any slight confusion, what you do? After the class, take the question, whatever plotting I have done, you do it on your own. Once you do it on your own, you'll get more clarity. Okay? Even if you have done it, but not very quickly, there are slight confusions, then also do it once again. Once you practice, that confidence that you get will be different. Okay, wonderful. Next question. I'm talking about step response and impulse response. I hope you know the relationship. Who will answer me this question? Step response and impulse response. Only if you know the relationship between them. That's a simple relationship. I think you all are aware of it. I'll revise that also quickly. But people who know what is the relationship between step response and impulse response, try to do the question. Simple math. It should be an easy question. It's an answer which you can type also in the chat. If anybody has done solving the question, you can type it in the chat. It's an easy, simple thing, simple to type kind of question. The answer will be easy to type. Is there anyone, any star who has done it already? Very nice, Rajat. Maybe there can be simpler version of it to type. T plus 3 into u of t plus 3. You can write it as r of t plus 3. Correct? R of t plus 3. Yes, but your answer is perfect. So Rajat, very nice. Anyone else? Simple differentiation funda. Only thing is you should know the relationship between step response and impulse response. Step response we denote it with S of t. Impulse response we denote it with H of t. Okay, and the relationship between both of them is impulse response is differentiation of step response. I'm not going into the basics of how do we get step response from impulse response. I'm just giving you the formula for now. So in some other class where we are discussing basics, I'll go into the depth of it. But for now, I'm just giving you the formula. Okay. Now H of t is equal to differentiation of. Look at this one. Is it not looking like I'm just trying to trick you by making sure that this is looking complicated, but actually this is not complicated. It looks like this simply. T plus 3 whole square into u of t plus 3. Even if you have not observed this also, that should not be a problem. You will be able to solve it easily. Even directly, if you are not writing this in this manner, then also the question answer will be same. Okay, and it will not become lengthy also in this way also. If you do, it will not become lengthy. It is easy only. So whether you write it this way or not, it should not matter. Okay, fine. So let us substitute it here. Okay, I am taking it as t square plus 6t plus 9 only into u of t plus 3. So let's differentiate. So it's like UV rule. Let's apply UV rule. Differentiation of this part is 2t plus 3 plus 9 differentiation is 0 into u of t plus 3. U dash we have done plus uv dash t square plus 6t plus 9 into u of t plus 3 is del of t plus 3. Okay, or you can also write it as t plus 3 whole square. So which is equal to, my mistake here, t differentiation is 6. So 2 if I take it common, it becomes t plus 3 into u of t plus 3 plus, how about this one? Impulse is there. Whenever there is impulse multiplied, identify the location of the impulse. Location of the impulse is t equal to minus 3. Substitute t equal to minus 3 in this one. Minus 3 whole square plus 6 into minus 3 plus 9, it will become 0 because this is nothing but t plus 3 whole square. No? If you put t equal to minus 3 plus 3 will become 0. So this also can be written as 2 times r of t plus 3. Okay. Very nice. So I'm using the smart board for the first time or second time I think. So that's why I'm not able to write very neatly. So excuse me for that. So next classes it will be better. Okay. Shall we move on to the next question? Any doubts? Anything you want to ask in this problem? Similarly, if impulse response is given, you can find the step response. It's the reverse relationship. If impulse response is given, if you want to find step response, integrate impulse response to get step response. It's the reverse relation. So it's a very common question that will be asked based on a relationship between impulse response and step response. Okay. So I'm moving on to the next question. If you have anything to stop me, you can stop me. Otherwise, I'll move ahead. Next question is based on Fourier series. So don't look at the signal and be afraid of it because it looks like a little complicated. A Fourier series is all questions are always based on most of the time they are based on common sense questions. You just need to observe the symmetry in it and try to answer the questions. Don't look at the options and be afraid of it. They're looking very complicated, but still you can try to answer it in a very commonsensical way. Try and figure it out. I'll wait for a few minutes, a minute or two, and after that I'll answer it. That signal, I've given you a periodic signal. I've plotted the graph only within one period. Signal is shown only within one time period. You can repeat that. You can periodically repeat that, and you can imagine that signal is what is given. So trigonometric Fourier series expansion of a periodic signal is given as 4 options. Which option will be the correct option for that signal? Only thing that you need to do is you have to figure out the symmetry. If you can figure out the symmetry, you don't need to calculate. Don't do the mistake of calculating. If they have given you an NAT type question, numerical answer type question, if they have given you a blank, then definitely you have to calculate if they are asking some particular coefficient. But here we don't need to. First of all, let us not find the coefficient unless it is compulsory. Let's try to figure out in a commonsensical way. Most of the Fourier series questions are based on symmetries. Even symmetry, odd symmetry, half-wave symmetry. Only these 3 things. Based on these 3 things, we can find out what terms will be existing, what terms will be not existing in the Fourier series expansion. We'll try to answer it only using that procedure. Even after that, using that approach also, if you are not able to answer, then only you'll use the formula or something to solve the question. Mostly formula based questions they will not ask because they'll be time taking. Most of the time they'll be time taking. But sometimes they'll ask you those questions also, but they'll make sure that the time taken to solve will be less generally. What symmetry is existing there? Anyone can answer me that? What symmetry? Only 3 symmetries, even, odd, half-wave symmetry. Is it having even symmetry? Obviously, we can rule out the even symmetry. Even symmetry means whatever is here, same thing should be here. That is not happening. So, even symmetry, not existing. Let us check for odd symmetry. Let us check for odd symmetry. Is odd symmetry existing? If you want to check for odd symmetry, what you should do? If a signal is x of t, it should be same as minus x of minus t. It should be same as minus x of minus t. Which means x of t is given. Find x of minus t. X of minus t means just invert it with respect to y-axis and then apply a minus n. Applying minus n means inverting with respect to x-axis. I'll tell you a small technique here. Okay, plot x of minus t and then apply minus n and then compare it with x of t. If that is same, then that is odd symmetry. That is a very basic way of doing it. Let me tell you a much easier procedure. Okay, and what is that easier procedure? Whatever signal you have, I will not disturb the total signal. I will only disturb the positive part, positive time part. What I will do is this positive time part signal, I will apply x of minus t. Only for this part I will find x of minus t. If you find x of minus t, how does it look like? It is going to look like this. Only for this part, if you plot x of minus t, this is how it looks like. And if you apply minus sign to that, if you apply minus sign to that, it is like inverted signal with respect to x-axis. So applying minus sign to this, all positive amplitudes will become negative amplitudes. It is going to match with this, no? X of minus t, and if you apply minus sign, it is same. It is matching with x of t, which is already existing. Okay, same thing you can do this for this part also. This part will match with this. Okay, instead of doing for the total signal, I am doing it only for the positive time part, and I am inverting and then applying a minus sign. If it is matching with the already existing one, yes, it is having odd symmetry. I hope you are following. Very basic procedure is find this one, apply minus n and then compare with x of t. That is a very basic procedure. Same thing I am telling you as a technique. Okay, anybody frames a technique based on the basics only, not from some other things. Okay, based on the basics only. If you observe basics properly, then only you can frame techniques out of it. I hope you understood the technique. For even symmetry, what you do? X of t equal to x of minus t. That is the relationship. So invert the signal with respect to y-axis. If already whatever signal is existing, if it is matching with that one, then it is having even symmetry. Okay, so it is having odd symmetry, correct? Perfect. If one of odd or even or odd symmetries are existing, then also half-wave symmetry can exist. if both these symmetries are not existing also, half wave symmetry can exist. Okay, half wave symmetry, or specifically half wave odd symmetry, can exist without these two or with these two also. Okay, so that's why we have to compulsorily check half wave symmetry, half wave odd symmetry. Even if it is not there, then odd you have to check. But irrespective of presence of even or odd symmetry, you have to check for half wave symmetry, because that symmetry is not dependent on these two. And that's a separate thing. Half wave odd symmetry. What is the relation for half wave symmetry? Half wave odd symmetry particularly. Half wave even symmetry we are not interested because that rarely exists. So half wave odd symmetry is what we are interested. The relationship is x of t is equal to minus x of t plus t by 2 or t minus t by 2. The meaning of this is shift the signal by half of the time period towards right side or towards left side, anything is fine, and then apply a minus sign. It should match with the original signal. Okay, so let me tell you it as a technique. Shift the signal by half of the time period. I'm shifting only this part. Let us not shift this part, only this part let us shift. This part, let us shift it by half of the time period. If you shift this by half of the time period, what happens? It will come here. Correct? And then apply minus sign. It will match with this. It is matching with already existing signal, which means this part and this part x of t are same. X of t is already existing part, and x of t plus x of t minus 4 we have plotted this part, and I have applied minus sign. It has become this much, this part. It is matching with already existing x of t signal. Instead of doing for the total signal, you can do for the total signal completely fine. If you are confused a little bit, what you do is do it for the total signal. So shift the total signal by t by 4, and then apply minus sign. Okay, and then see if it is matching with the original x of t signal or not. This is not the original x of t. Okay, this is only part of x of t. I've given you only part of the periodic signal, so you have to repeat this. You have to repeat this. That is the original signal. I hope you're following. Is it clear till this point? So this is a very interesting topic, and very commonsensical questions will be asked here. So once you understand these symmetries and what happens if those symmetries are existing, then you can easily answer the questions based on Fourier series. Okay, right? If it is having even symmetry, what does it mean? In trigonometric Fourier series, cos terms can be there, sin terms also can be there, and constant term also can be there. If it is having even symmetry, sin term should vanish, no? Because sin term is odd. If odd term is there in the Fourier series expansion, the total signal will not become even. So if we are talking about even symmetric signal, only cos term should exist. If we are talking about odd symmetric signal, only odd terms should exist, which means sin terms will be there. Only sin terms should exist. Constant term also should not exist, because constant term is even symmetric. And half wave odd symmetric means whenever half wave odd symmetry is there, only odd harmonics will be there. Only odd harmonics. In trigonometric Fourier series expansion or any Fourier series expansion, you will be having harmonics. You will not have all frequencies, no, you will have multiples of a certain fundamental frequencies. Cos omega naught t, cos 2 omega naught t, cos 3 omega naught t. Which means frequency like omega naught, terms with frequencies omega naught, 2 omega naught, multiples of omega naught will be existing. Okay, omega naught, 3 omega naught, 5 omega naught, these are odd harmonics because they are odd multiples of fundamental frequency. And 2 omega naught, 4 omega naught, 6 omega naught, these are even multiples. Even multiples of fundamental frequency, we call them as even harmonics. When there is half wave odd symmetry in a signal, is there a half wave odd symmetry in this signal? My mistake here, I have done a small mistake here in plotting. I've done a mistake here in plotting. So this one, x of t minus t by 2. If you shift this by t by 2, this is how it looks like. Correct? This one, if you shift it towards by t by 2 towards right side, you can shift it left side also. This one shifted by t by 2. This is how it looks like. If you invert it, if you apply minus sign, what happens? This is the signal that you are going to get. This is the signal that you are going to get. Is it matching with the already existing signal? No. No, it is not. It is not matching. So half wave odd symmetry is not existing. There is no half wave odd symmetry. Only odd symmetry. If there was half wave odd symmetry, only odd harmonics will exist. Even terms will vanish. But there is only odd harmonics. Only odd symmetry is there. Only odd symmetry means, will there be any absence of any harmonics? No. Only half-wave odd symmetry will make sure that there is absence of even harmonics. Okay, since there is no half-wave odd symmetry, there is no confusion regarding that, which means all frequencies will exist. But all frequencies of sine will exist or cos will exist? Because only it is having odd symmetry, only sine terms will exist. Because only sine terms are odd symmetric, right? So see the options. There are 3 options with sine terms. There are 3 options. Sorry, 2 options. 2 options with cos terms and 2 options with sine terms. This we can rule out. This we can rule out because both of them are even. All the signals are even here. Cos, all cos terms means even symmetric. Addition of all even symmetric signals is even symmetric. So this total signal is even symmetric. So this should be the Fourier series expansion of some even symmetric signal. This also should be the Fourier series expansion of some even symmetric signal. Okay, right. But if you observe, what is the fundamental frequency here? Can you tell me the fundamental frequency here? Fundamental frequency is 2 pi by t. 2 pi by t. What is time period t here? Total width of the signal is pi units. You can substitute that pi. So it is 2 radians per second. 2 radians per second is the fundamental frequency. 2 radians per second. So what frequencies will exist in the Fourier series expansion? Multiples of 2, which means 2, 4, 6, 8, all multiples of 2. So 2, 4, 6, 8, all multiples are existing here. See this one, 2, 6, only odd harmonics are existing here. But though this is not an option because cos terms are there, where we have ruled it out because this will be the Fourier series expansion of some even symmetric signal, not this one. But this will be the Fourier series expansion of even signal with half-wave odd symmetry. If it is a signal with even symmetry and half-wave odd symmetry, then this would be the Fourier series expansion. Okay. Now let us come to the B and C. In B, only sine terms are there. Combination of only sine terms. Sine terms are odd terms. Odd symmetric, odd symmetric, odd symmetric. If you add all odd symmetric signals, the resultant signal will be odd symmetric. So the total signal will be odd symmetric signal. So this is the Fourier series expansion of some odd symmetric signal. See the next one? All sine terms. Yes, this is also the Fourier series expansion of some odd symmetric signal. Yes, correct. But see the frequencies. Here all the frequencies are present. All the harmonics are present. Fundamental harmonic 2. Fundamental frequency is fundamental harmonic. Frequency or harmonic. The harmonic is nothing but the other word for frequency, you can say. So fundamental harmonic or fundamental frequency is 2 units. So 2 and all multiples of 2 are existing. So all frequencies are present. So this is the Fourier series expansion of a signal with only odd symmetry. And this is the Fourier series expansion of a signal with odd symmetry and half-wave odd symmetry also, because odd harmonics are missing here. Okay. For the given signal, only odd symmetry is there, which means this is the best choice that we can make. Okay. I hope you're following. Can I move ahead? Any confusion? Just watch this part. Whatever question you have a confusion, just watch that part of the video once again. Okay. I'm moving on to the next question. Come on. I've given you step response. I'm asking about stability. How about stability? Stability. If you know impulse response, then you can comment about stability. Generally, stability cannot be stability. Can we comment using step response? Yes, I think we can comment using step response also. But using impulse response, we have a formula to comment about stability, right? If integration of mod h of t dt limits from minus infinity to plus infinity, if that is less than infinity, or the statement for this will be, is h of t absolutely integrable or not? If this happens, we can say h of t is absolutely integrable. Absolute because, absolute word we are using because we are applying absolute on top of this, and then we are integrating. Absolute integrability. Absolute value is integrability. Integrability means the value should be less than infinity. So if this happens, then we can say that whatever system h of t is representing some system, that system is stable, or If this does not happen, what is the meaning of this does not happen? This value becoming infinity. If this value is becoming infinity, which means h of t is not absolutely integrable. In that case, system is unstable. Okay, right? We have step response. We have step response, and we know the relationship between impulse response and step response. H of t is the impulse response. How do you find it? Differentiation of step response will give us the impulse response. Let us differentiate this. It's very simple differentiation. U of t differentiation is del of t plus 2 into del of t minus 2. So h of t we know. Are they absolutely integrable impulses? No. The area of it will be 1. The area of this will be 2 units because 2 is multiplied here. The total area will be 3 units. So integration of mod h of t dt, if you integrate from minus infinity to plus infinity, these are both are positive only. If you apply modulus also, it will be same. If you apply integration for this, integration of this impulses, because this is a unit impulse, so integration will be 1 unit, plus integration of this impulse is also 1 unit. Since 2 is multiplied, it will become 2 units. Total, it will become 3 units. So it is definitely not infinity. It is definitely not infinity. So this impulse response is absolutely integrable. So whatever system this impulse response represents, that system will be a stable system. Yes, the answer is yes, it is stable. Okay. I guess it is a simple question. I hope you all have understood this one. Very simple stuff. We have already talked about the relationship between step response and impulse response. Now we are talking about stability. And I have told you the funda for stability. Generally we find stability using impulse response. Okay, there is a formula for using which we can find stability of a system. Using a step response also we can find, that we'll discuss some other time. That we have to come from the very basics. Then you can talk about stability using step response also. Next one. X of t is u of t minus 3 is given as input to an LTA system with impulse response. The output of the system is y of t. I am just simply giving, for an LTA system I have given input, I have given the impulse response, I am asking you to find the output, particularly at t equal to 8 seconds. So what should you do? You know the formula for, or the relation for output, input and impulse response. For an LTA system, the relation between input and output is x of t convolution with h of t. This is the relation between input, output and impulse response. So we want to find y of t at a particular time. So first find y of t and then substitute t equal to 8. H of t is, x of t is u of t minus 3 convolution with u of t minus 2. It's a very simple convolution. Whenever convolution is involved with impulses or step signals, it's very easy convolution. If a convolution is tough, if little complicated signals are there, complicated signals, always convolution is very tough. But when step signals or impulse signals are involved, it should be very easy. See this one, u of t and u of t. You know this relation, right? U of t convolution with u of t is r of t. I hope you are aware of this. Or whenever you are convolving with u of t, it's nothing but integration of the other signal. Whenever u of t is involved in convolution, integrate the other signal, that will be your answer. Anytime. There is some signal here, you are convolving with u of t. It is nothing but other signal integration, that will be the result. Okay. The reason is the impulse response of a integrator system is u of t. So which means whenever you are convolving u of t, you can think of it as, okay, you are passing a signal, you are passing this signal through an integrator system. When you are passing through an integrator system, you are convolving with impulse response of that system. And impulse response of integrator is u of t. Okay. I hope you are following. It's a very interesting topic. Okay, fine. U of t with u of t is r of t. That much we know. So u of t with u of t is r of t. Whenever there are delays, just add them up. You don't need to do anything more than that. Very simple. Without delays, you do the convolution first and then add up the delays and write the answer. So what is the effective delay? -3 and -2. Total delay is -5. Add along with the signs, okay, along with the sign. Don't forget to add without, don't add without signs, you have to add with signs. Minus 3 plus minus 2 is minus 5. So that is the answer, r of t minus 5. We got y of t, but I'm not asking you total y of t, I'm asking you only y of 8. Substitute t with 8, it is r of t minus 5, which is r of 8 minus 5, which is r of 3. You know what is r of 3? R of t is t into u of t. Okay, r of 3 is 3 into u of t, or 3 into u of 3. U of 3 is 1, which is 3 units. Okay. I guess all of you are following. Very good. Shall we move on to the next one? Okay. One more question on Fourier series. Same basics. Read the question carefully. A periodic signal is shown in the figure for one time period. Trigonometric Fourier series expansion of the signal has cos terms and DC, cosine terms and DC, only sine terms, only odd harmonics of cos terms and DC. Okay, I've given you 4 options. Okay, let us come the reverse way. Okay, when does a signal have only sine terms? If it is having only odd symmetry, correct? Only odd symmetry, then only we'll have only sine terms. Okay, is the signal having odd symmetry by any chance? Is the signal having odd symmetry by any chance? No, right? There is no chance. So this option we can rule out. Next, only odd harmonics of cos terms and DC. Cos terms they are saying. Cos terms means it should be even symmetric. Yes, we are able to see even symmetry there. Since even symmetry you are able to see, cos terms will exist. That much we are sure. We are sure. So there are 3 options with cosine terms and odd harmonics of cosine terms. If you want odd harmonics of cosine terms, there should be half-wave odd symmetry. Okay. So is there a half-wave odd symmetry? Visibly there is no half-wave odd symmetry. Visibly, by looking at it, you will say that okay, there is no half-wave odd symmetry, sir. Yes, but how should you check for a half-wave odd symmetry? Okay, you know the funda for a half-wave odd symmetry, but whenever there is non-zero DC, you have to be careful. What is the DC value here? What is the DC value or A naught value? A naught value is 1 by t into integration from 0 to t or minus t by 2 to plus t by 2 x of t dt. Within one period you find the area and divide it with the total time period. So what is the area of this one? 5 is the 25 is the area of this total triangle. Divide by, what is the time period? It is 10 units. 2.5 units is the DC value. Whenever there is a non-zero DC value other than 0, then you have to be careful. Okay, whenever you are talking about symmetries like this, first thing you have to do is, whenever you are dealing with half-wave odd symmetry, first thing you have to do is look for a DC value. If DC value is 0, then no issues. Half-wave odd symmetry, if it is there, it will be visible. Okay, this DC value, there is a chance that this can hide the symmetry. How it can hide the symmetry? Let's see. If you want to see whether there is some hidden symmetry or not, hidden half-wave odd symmetry or not, let us remove this DC. Who will hide the symmetry? This DC will hide the symmetry. If you remove the DC, there is nobody who can hide the symmetry. So symmetry will be visible. If it is there, it will be visible. I'm not saying that DC is non-zero means half-wave odd symmetry will be there. I'm not saying that. There is a chance. There is a chance that half-wave odd symmetry will be there. Hidden half-wave odd symmetry will be there. Okay. Okay. So let us remove 2.5 units from this. If you remove 2.5 units from this, then how does it look like? This is how it looks like. Height is 2.5. This is minus 2.5, correct? 0 becomes minus 2.5. This is how it looks like. And I have plot, this is only one period of the signal. If you plot the remaining periods also, this is how it looks like. It is clearly having even symmetry, which means we are definitely going to have cos terms, correct? We are definitely going to have cos terms because of even symmetry. So this is having even symmetry. And is it not having half-wave odd symmetry? See this one? This is the total time period. Remember the technique that I told you? Take half of the time period. Take half of the time period. This is half of the time period. Shift this by take half of the time, but I'm taking this part, shift this by half of the time period, only that part, remaining things as it is. X of t by t minus t by 2, I'm plotting x of t minus t by 2 only for a single part, and then apply minus sign to that. What happens? It will be looking like this. The blue one is x of t, and the red one is, this part is x of t minus t by 2, and this is minus x of t minus t by 2. It is matching. X of t minus t by 2 minus x of t minus t by 2 is matching with x of t, the basics of half wave odd symmetry. Hence it is having half wave odd symmetry as well. This is having half wave odd symmetry. Because it is even symmetry, we know that it will have cos terms. But there are three options with cos terms. Because it is having half wave odd symmetry, it will have only odd harmonics. We will have cos terms. Because it is having even symmetry, sine terms will vanish. Only cos terms will be there. But among those cos terms also, because of half wave odd symmetry, even harmonics will vanish. Only odd harmonics will be present. Only odd harmonics of cosine terms. Only odd harmonics of cosine terms. Option C is the only option that we are able to find for odd harmonics. But to be perfect, for this one, if I am talking about this one, this signal, the answer will be only odd harmonics of cosine terms. But I'm not talking about this signal, I am talking about this signal. The difference between these two signals is, if this is x of t, what is this? This is x of t minus 2.5, correct? Okay. So this Fourier series expansion of this will have only odd harmonics of cosine terms. Now if you send 2.5 onto the other side for this one, for the Fourier series expansion of this one, you got the Fourier series expansion for this part, x of t minus 2.5 as odd harmonics of cosine terms. But you want Fourier series expansion for x of t, which means this 2.5 minus 2.5, you send it onto the other side, then the DC term will be there, no? They're talking about this signal, not this one. So this signal has a non-zero DC, yes. So DC will be non-zero. So the answer will be, DC also will be present along with cos terms, that to odd harmonics. So answer is option C. So points to remember here is, whenever there is non-zero DC, there is a chance of hidden symmetry, which means half wave odd symmetry or other symmetries also. Sometimes odd symmetry also might be hidden. Sometimes there is a chance. Even symmetry, there is no chance of hidden symmetry. Even symmetry, because if you add DC value, what happens? It gets lifted. If it gets lifted, if there is already even symmetry, even if you lift it also, it will be even symmetry only. Okay, even symmetry is always visible only. It can't be hidden. Odd symmetry, sometimes we can hide it by adding DC. For example, if you take a rectangle, square wave periodic waveform, positive cycle, negative cycle. If you add that with DC, what happens? Everything gets lifted and it looks like there is no symmetry in that. But if you subtract DC from it, then there will be hidden odd symmetry along with hidden half wave odd symmetry also. So odd symmetry and half wave odd symmetry can be hidden with the help of DC. If there is non-zero DC, there might be, I'm not saying 100% there will be there. It's not, I'm not saying 100%. There are chances that there might be some hidden odd symmetry or hidden half wave odd symmetry, or both of them also, hidden odd and half wave odd symmetry, both of them. That is possibility. So whenever DC is non-zero, remove the DC. If you remove the DC, then if there is any symmetry that is being hidden by DC value, that will be visible. Okay. I hope it is clear. Very nice. One more. Again, I am asking you to find the output of an LTA system. You know the relationship. I have just, in the previous 2 slides back, we have discussed about it. X of t convolution with h of t. But we don't have any remembrance about convolution of negative time signal. This is a time signal which exists in the negative time, right? So we have to use some property here to do it easily. Yes, you can do it using regular, there are a lot of procedures to do convolution. You can use any procedure. You will get the answer definitely. Any procedure you will get the answer. But I want you to do it the smartest way or the easiest way possible. The way in which you can save a lot of time. That is the way that we want. Okay. So if you want to do that, you have to use effectively the properties of LTA systems. Okay. So whenever you are having this kind of relation, if you invert x of t and h of t, then the result is going to be inversion of y of t. There is no property that only if you invert x of t, what happens to f t? There is no such property. Only if you invert h of t, there is no property. If you invert both x of t and h of t, both of them, the result is, you can find it easily. Whatever is the original result of convolution of x and h, the convolution of inversion of x and h will be inversion of y. This is the only property that is existing. Only one of them inverted, there is no property that will be there. Because there is no observable result. There is no result that we can remember. Okay. So this result is there. Okay. Fine. Now, look at this one. Understand it carefully. Okay. So I'll remove this minus sign. I'll remove this minus sign. The time reversal part, I'll remove it and I'll find it. U of t convolution with U of t is R of t. This much we know, right? Correct? U of t minus 1 convolution with U of t plus 2. U convolution with U is always R. Whatever delays are there, just add them up. Minus 1 plus 2. What is minus 1 plus 2? It is plus 1. But this is not what we want. We want this one. Think of this as x of t, think of this as h of t. Look at this one as x of t. Look at this one as h of t. And look at this one as y of t. Okay. Now, u of minus t minus 1 is nothing but x of minus t. Wherever t is, they are replacing with minus t. Convolution with u of minus t plus 2. Why am I writing these things? Because that is the result that we want. We want convolution of these two. Okay, to find the convolution of these two, I am trying to get the answer from known results. I am getting it from some known results. Okay, so this is looking like h of minus t. What should be the result? The result should be something like y of minus t. This y of t is different, this y of t is different. This I am just doing it just to link it with this formula, this relationship. Okay. So what would be y of minus t? The result we know, it is r of t plus 1. If you replace t with minus t, it will become r of minus t plus 1. Is that okay? R of minus t plus 1. So the answer is r of minus t plus 1. We want to find the convolution of these two. I got a thought that, okay, I can use the time reversal property of LTE systems. Okay, so I got that idea. Using that idea, okay, I'll write the signals without that time reversal thing. I will find this first and then I can find that easily. So I've converted this problem into without time reversal problem first. I found the answer. Using time reversal property, we can find the answer very easily. Is that okay? You can use other procedures also. You can use mathematical procedures. You can substitute the formulas directly. You can integrate. You know the formula, integration formula for convolution integral formula. You can use that also. You can use different procedures. There are multiple ways of finding convolution. Using Laplace transforms also you can find. You can use Fourier transforms also to find. There are multiple ways. But I would say this is the easiest, if you get the idea. Okay. Shall we move on? Let's move on to the next question. Wonderful, guys. I think some tricky questions I'm taking. I think for the last few questions, there is no response from you guys. Should I take only the easy questions? One more interesting question. One more very interesting question. This is an easy question only. It looks like a complicated one, but it's an easy question. Don't be afraid by looking at the question. Read it carefully. Try to understand it carefully. It will be an easy question. A signal x of t is passed through 3 LTE systems connected in cascade. The impulse response of the 3 systems I have given. I did not ask the question. Find the output. Find the output of the system. Whenever systems are cascaded, I'm giving you the basic first. If you know the basic, you can do the question. So let me say h1 of t is the impulse response of the first system, h2 of t is the impulse response of second system, and h3 of t is the impulse response of third system. Okay. Now these three systems, whatever task they will do, finally, if for some input, whatever output these three systems together will produce, same output will be produced if you are passing it through a single system, which is like an effective system for all these three. And systems are connected in cascade, only LTE systems. This basic is not applicable for other systems, only for LTE systems this is applicable. It's like convolution of the effective system of all these three systems together is just convolve the impulse responses, individual impulse response of three systems. You'll get an effective impulse response, which is the impulse response of the cascaded system. All three systems together will behave. You can represent it as a single system whose impulse response is convolution of individual impulse responses. Whenever multiple systems are given, convert it to a single system like this and do it. If it is only two systems, only h1 of t and h2 of t will be there. Okay, right? Shall we find this? So here I have given h2 of t is d by dt of r of t. You know this, right? It is u of t. And d by dt of u of t is what? Del of t. Step differentiation is impulse. Ramp differentiation is step signal. Now we want to convolve these three. So result is del of t, convolution with u of t, convolution with another u del of t, which is, how much is that? Del convolution with anything is the same thing. Del with u, convolution is u only. U with del is u only. Anything convolved with impulse is the same thing. So impulse convolved with impulse is impulse only. Impulse convolved with u will be u only. Okay. So result is u of t. When you convolve anything with impulse, it's the same thing. Del of t with u of t. The result of these two is u of t. The result is u of t. U of t convolution with del of t is again u of t. When this impulse response is u of t, what system is that? If you have recognized, the answer will be very easy. If the impulse response is step signal, if impulse response is step, it's an integrator. For an integrator system, impulse response is u of t. Okay, right. So the signal is e power minus 7t into u of t. The output of this system. If you can recognize that it is integrator system, you can directly do integration. If you have not recognized that, you can go with regular procedures of convolution also. Answer is e power minus 7t into u of t, convolution with u of t. Because impulse response of this system, all three systems together is u of t. So whenever you are seeing convolution with u of t, you have to understand that, okay, we are passing this signal through an integrator system. So integrate this one. Integration means the limit should be from minus infinity to t. Somebody says find the area of the signal. Limit should be minus infinity to plus infinity. For all time you have to integrate. When somebody says integrate, the meaning is, oh, you should be integrating from minus infinity to t, small t, which is the time variable, which means the present time. Integrate till present time. Find the total area means, it's like find the area for total time. When somebody says just integrate, okay, find the area till the present time. That's why the upper limit should be t. If upper limit is infinity, the result will become a constant. It will not become a function. So it is e power minus 7t into u of t. You can integrate this. It becomes e power minus 7t divided by 7. Is that okay? Wonderful. Some of you have done it. Very good, Shojit. Very nice. Into u of t also. I missed it. Very nice. Shall we move ahead? There is a very important basic I told you regarding cascading of systems, cascading of LTA systems. Cascading of other systems, there is no such funda that we have learnt in our textbooks, in our course at least. There might be some theory, but we have not learnt it in our course. I mean, in our signals and systems course, in our engineering studies. That's it. So the problem set that I have collected is over for today. So tomorrow we will be discussing some more questions. Another 15 questions we will be discussing in tomorrow's session. The timing of tomorrow's session is different. It is at 6 o'clock. At 6 o'clock, same session, we'll continue. We'll discuss some other interesting questions based on other topics, Fourier transform, Laplace transform, other topics as well. Yeah, Shankar, you are asking something, limit having t. Yes, upper limit is t. When you're talking about integration of a signal, find the integration of the signal means result should be a signal, no? Which means a function, it should be a function of some variable. Whatever is the variable that you're talking about, that should be the upper limit. If you're talking about a function of x, there is a function of x and you are going to integrate that function. The result, if you want the result to be a function, upper limit should be x only. Upper limit should be the variable. Otherwise, it will become a constant. See, if upper limit is infinity, what happens? This will become a constant, right? It will not become a function. When you say integrate a signal, you want another signal. Okay. Shankar, hope that I have answered your question. You are asking anything different from what I have answered? Okay, fine. So that's it, guys, from my side for today. So any questions, if there is any slight confusion from your side, if you're not able to understand anything or if you're not very clear about anything, you can go through that part of the video once again, and if still there is a doubt, try to figure it out yourself, and if you're not able to do that, then you can ask me for help. You can follow me on the Telegram group. I'll show you my Telegram group. Yeah, you can search with this name in Telegram. So I'll be available on this Telegram group. So if any question you have, any question is still troubling you, I'll definitely help you. You can post it in the group, or you can search my name. With my name, you can type in Telegram. You can ask me personally also, but I would prefer asking questions in the group because it will help other students as well. Same students, some other students also might be having the same doubt. They also will get help regarding that question. He might be hesitant to ask the question, you are asking the question. So it will help him also, right? So that's why I would prefer, if any technical doubts you are having on my subjects, you can ask in this group. If you are having any other personal doubts like how to study or something like that, or you got a rank and how to proceed, something like that, if you need my help, then you can contact me personally. Or if you want, you can contact me in the group also. Anything is fine. I'm there to help you. Okay, guys, and I told you one more session tomorrow at 9:30. I'll be discussing about life at IIT. Very interesting session. I'll be sharing my stories, a lot of interesting stuff. That will be a general session, okay? No subject. That will be a general session, general talk. Okay, if you're interested, you can join. So definitely some very interesting points I'll be telling you. Some things that I could have done better in IIT. The perspective with which I should have gone to IIT rather than what I've gone. If I've gone with a different perspective, then I would have got more out of it. Okay, all those things I'll be discussing. Okay, fine then. Thank you. Good night. Have a good day. Practice well. And I think the result is upcoming, so don't get tensed. It will be fine. It will be according to. It will be for good. Whatever result comes, understand that it is for your own good. Okay, the result is gonna. If the result is bad, it does not mean that it is not the end of life, right? This is only one phase of our life. There are multiple phases. There are multiple challenges that we're gonna face. This is only one phase. Okay, so even if the result is positive, also after a few days, that will be nothing. You'll be forgetting about it, right? So just think of it as a single phase of life, but not the total life. Okay, don't think that this thing will decide my complete life. No, it is like one small part of your life. Okay. And I'll take one more session also. So means if you get low score in GATE, so how should be your thought process? That is also one session I wanted to take, so that it will help a lot of students. Fine, guys. So next 3 days I'll be taking classes. Tomorrow I'll be taking signals class and life at IIT class, and day after tomorrow and other day I'll be taking communications class. Similar type of class will be there, so you can attend if you're seriously preparing for BARC, HAL or any other exam. Or if you're preparing for next year also, you can test your knowledge here. Fine. That's it, guys. Thank you.